Okay, looking at another homework sheet for my grade 9 class. So going through the answers with this, it may be helpful to you for revising your measurement and trigonometry questions as well. So looking at the first question, so in these ones we are calculating the area of each of the shapes. So when we see this one, we know it's a triangle, so we're going to write that its area is a half of base times height. Then we're going to put in the base and the height. So we've got 7.5 and 11. So we've got a half times 7.5 times 11. We grab our calculator. We're going to type that in. And we get 41.25. And that will be meters squared. The next one over here we have is a circle. So we're going to write area equals pi r squared. Our radius in this case is 4, so we've got pi times 4 squared. So we pop that in our calculator and we get 50.265. So I'm going to round that to 50.27 and it's millimeters squared. Here we have a parallelogram. Now it doesn't have the little indications on there that it is a parallelogram, but in my class, they're used to recognising that shape as a parallelogram. When we see a parallelogram, we know that it is base times height. We've been given the base is 11 and our height is 10, so our answer is going to be 110 metres squared. Next to that, we have a trapezium. It could also do with the indications on there that they're parallel lines, but as I said, we know what this shape is, so my students knew to recognise that as a trapezium. So we've got area is a half of a plus b times height for trapezium. Our a and our b are the 7 and the 5 here, they're the parallel lines. So we've got a half of 7 plus 5 and we're multiplying that by 4. So then we can pop that in the calculator, 0.5 times, and then we can use the brackets and pop that in and then times 4 and we'll get 24. We could also have gone 7 plus 5 is 12, a half of 12 is 6 times 4 is 24, and we've got kilometres squared. Here we've got a combined shape, or a composite shape. So we've got a rectangle, and we know that our rectangle is length times width. Then we've got a semicircle, and we know that that'll be a half pi r squared. We know our length and our width are 12 times 5 here, and with our radius, we know that it's 12 the whole way along, so halfway along is going to be 6. So our radius is going to be 6 for that. Now my 12 times 5 is going to be my 60. And then I've got a half times pi times 6 squared. And I get 56.55. So when I add that to the 60, I'm going to get my 116.55. And that will be centimetres squared. The last one of our area calculations we have is a shape. Now we can put a little dotted line across here so that we've got a rectangle and we've got a triangle. Now we know the height of our triangle is 5, the base of our triangle is 20, and then we've got the rectangle that is 20 by 40. So we've got the length times width for the rectangle, and then we've got a half of base times height for the triangle. So we've got 20 times 40, and then we've got half times 20 times 5 for the triangle. So we've got 80 plus, now my 20 times 5 is 100 and a half of 100 is 50. So I get 80 plus 50 is 130 kilometres squared. So then we go on to our converting units. Now in this one we're converting to centimetres squared. So we've got metres. And if I was just going metres to centimetres, I would times by 100. But because I've got metres squared to centimetres squared, I'm going to do 100 squared. So I've got 3 times 100 squared, and I get 30,000. Going back the other way, I would divide by 10 if it was just millimetres to centimetres, but I've got squared, so it's dividing by 10 squared. So I do my 200 divided by 10 squared, and I'm going to get 2 centimetres squared. So my answer for that one was 2 centimetres squared. Now I come down to the next one. I've got 0.004 metres cubed. Now, if I was just going meters to centimeters, I would times by 100, but I've got the cubed, so I'm timesing by 100 cubed. So I've got 0.004 times 100 to the power of 3, and I get 4,000. Then going back the other way, millimeters to centimeters, I would normally divide by 10, but I am doing cubed, so I need to divide by 10 cubed. So I'm going to go 3,000 divided by 10 to the power of 3, and I'm going to get 3 centimeters cubed there. Okay, moving on to the second side of the sheet. This was a 4-page one. I'm only going to go through the first 3 because the fourth one was probability and they were all multi-choice questions. Okay, surface area of a cylinder. We know that that is 2 pi r squared plus 2 pi rh. In the exam, my students will be getting a formula sheet, and that will be on their formula sheet. In this case, I've been given my radius and my height, so I'm going to 2 times pi times 7 squared plus 2 times pi times 7 times 20. So I'm going to grab my calculator and do that calculation, and I get 307.88 for the first part, and I'm going to get 879.65 for the second part, and then I'm going to add those two together. I'm keeping all the decimals in my calculator so that when I add them together, I'm not keeping the rounding one and having it continue on. So when I kept all the decimals, I got 1187.52 centimeters squared for that one. Obviously, if you'd use the rounded numbers, it's going to be slightly different. Now, we've got over here our box. Our surface area for that is going to be 2LW plus 2WH plus 2LH. Now, this one isn't on the formula sheet, but you can break that into the different shapes. So we've got 2 times 11 times 2 plus 2 times 2 times 5 plus 2 times 11 times 5. And we will work those ones out. And we get 44 for the first one. We get 20 for the second one. And we get 110 for the third one. Then we're going to add them up. And we get 174 meters squared. Now over here we have a shape where we've got a triangle at the front and the back. We've got a rectangle on the bottom, and we're assuming that these two sides are the same. Since we don't have the other dimension given to us, we just assume they are the same. So when we do our surface area, we've got 2 lots of a half of base times height for the triangles. Then we've got 2 lots of those sides that are going to be 8 times 3. And then we've got the base, which is the 4 times 8. So we've got a 2 times half times 4 times 2.5. Then we're going to add to that the 2 times 8 times 3, so that will be 48. And then the 4 times 8 is 32. So when I do my 2 times half times 4 times 2.5, I get 10 plus 48 plus 32. When I add that all up, I get 90 centimeters squared. Coming down to the bottom here, I'm now working out volume for those same shapes. So I've got a volume equals pi r squared times height. So I've got pi times 7 squared times 20. Pop that in my calculator. And I get 3078.76, and that will be centimeters cubed. Here my volume is length times width times height. So I've got 22 times 4 times 10. And I get 880 millimeters cubed. And then over here, my volume is going to be the area of the base, which will be my triangle, times by the height. So I'm going to do my half times 4 times 2.5, and then I'm going to multiply that by 8, and I get 40 centimeters cubed. Okay, on to our last page. We've got some Pythagoras and some trigonometry. So the first row here, are going to be Pythagoras theorem. So I'm going to go through and label my triangles first. So here I've got my C on the 15, and then I can put my A and B on either of those X and 11. Here I've got my C on the 22, because that's my hypotenuse there, and then my A and B can go on either of those. And then over here, I've got my C on the X, and then my A and B can go on either of those sides. Now I'm going to go back and write my formula. C squared equals A squared plus B squared. I've got 15 squared is equal to 11 squared plus X squared. Now to get the X squared on its own, I'm going to do 15 squared take away 11 squared. And I get 104. So to get my X, it's the square root of 104. So I'll do that on my calculator. And I get 10.198. So I'm going to round that to 10.2. And that will be meters. Okay, on the next one, same thing again. C squared equals A squared plus B squared. 22 squared is equal to X squared plus 15 squared. To get my X squared, I'm going to do my 22 squared take 15 squared. So I'll do that on my calculator. And I get 259. So my X is going to be the square root of 259. And I get 16.09 as my answer there. Centimeters. Oh, I do have a little thing here. This one's in meters, this one's in centimeters. So I probably should go back and do that again. I'm going to assume that I meant to have them both centimeters, because otherwise those numbers would be quite wacky. But if I was an exam, I really should change that to centimeters and go from there. I think most of my students will assume it's centimeters for both of them, so I'll leave that as it is. Over here we've got our C squared equals A squared plus B squared. So we've got X squared equals 8 squared plus 10 squared. 8 squared plus 10 squared gives me 164. So my X is going to be the square root of 164. And that gives me 12.81 centimeters. Then we get onto our trigonometry. So I'm going to go through and label these, and then I'm going to come back and work them out. So here we've got our hypotenuse, our adjacent near our angle, and then our opposite. Here I've got my hypotenuse opposite the right angle, my adjacent right next to the angle, and my opposite. Here I've got my adjacent side next to the angle, my hypotenuse there, and opposite. Down the bottom here I've got adjacent, hypotenuse, opposite. This one tricks out some students because it's a little bit upside downy. Here's my H on the X, my adjacent here, opposite, and then the last one I've got my adjacent, opposite, hypotenuse. Now, once I've labelled, I then circle which to have something with it. So these are A and H. So it's cos theta equals adjacent over hypotenuse. Here we've got something with the A and the H, so it's going to be cos again. Here again we've got our A and H. Obviously I was loving my cos questions in this set. Then down the bottom here I've got O and H, so that is going to be a sine theta 1. Here I have got O and H again, so another sine theta. And here I've got O and H, which is another sine theta question. Now going back to solve these, I'm going to put in what I know. So I've got my cos theta is A over H, so I've got X over 13 is cos 70. So my X is going to be 13 cos 70. So I'll grab my calculator, pop that in, and I get 4.446, so I'll round that to 4.45. And that is millimeters. Here I've got my adjacent is 5, my opposite is X, and I've got cos 80. So this is where the X is on the bottom, we make them switch sides. X is 5 on cos 80. So I'll grab my calculator, 5 divided by cos 80, and I get 28.793. So I can put it as 28.79, or I could round to 28.8, and that is kilometers. And then we've got here, our adjacent is 5, our opposite is 19, so we're actually solving for the angle. So we'll write theta is cos to -1, 5 on 19. So we'll go shift cos and put in 5 divided by 19, and then we get 74.74 degrees. This last row is just matching with the ones above, so the same process, just different ratio. So here we've got sine of 70 is x over 20, so our number is on the bottom, so we will multiply. So I've got 20 sine 70 is equal to 18.79, and that is centimetres. Here I've got my sine 70 is equal to 10 over x. The x is on the bottom. We're going to make them switch places. So we have x is equal to 10 over sine 70. Grabbing the calculator, 10 divided by sine 70. And we've got 10.64 millimetres. Then our lucky last one, we've got sine theta equals 15 over 22. So our theta is going to be sine to -1, 15 on 22. I'll grab my calculator, second sine, 15 divided by 22, and I get 42.98, and that's 42.99 degrees. And we could round that depending what we're told to round to. We could even round that to the nearest degree and say that that is approximately 43 degrees. Okay, hope that was helpful. And those who are watching, working on their homework, hope that helped you get your homework completed.